So those who are online, are you able to see my screen? Shall we proceed? Those who are online, can you respond?
Yes, sir.
Yes, sir.
So you all can keep your videos on. Others?
So give me a second, I'll turn it on.
Sorry?
I'll turn it on in a minute.
Okay, but I'm not able to see. Shall we proceed? Yes. So yesterday, what were the concepts that we saw? Let's just try to 1 minute. I need to record it. It's fine. So what were the concepts that we saw yesterday? So first thing we understood, see, let's come in the order. Okay, first we understood that for you to define something called as a relation, you need two sets, right? Those two sets need not be different. They can be the same also. That's the lesson we learned yesterday, right? So if you have those two sets, you perform a mathematical operation between them, which is called as Cartesian product, due to which you get another set. So what is the name of that set? It's going to be the ordered pair set. So we know why they are called as ordered pairs, because the order in which the numbers or whatever elements are written is important, right? From that ordered pair set, if I take a subset of the requirement that I have, that is going to give me relations, right? And when you write that relation, you will have another ordered pair set. In that ordered pair set, the first element, the set of the first elements are called as a domain, and the set of the second elements is called as range. Then what is codomain? You need not participate in the relation. So where do you get the codomain from? Do you get it from the relation set, or you get it from the ordered pair set? You get it from the ordered pair set, right? From the ordered pair set is what you're going to get. So I hope till here we are clear, right? We saw some problems also yesterday. I'm assuming the remaining problems you guys could handle, right? So today what we are going to do is we are going to see the next important topic of this chapter, which is functions, which is very, very, very important. As I told you, right? Functions is not restricted only to this chapter. Rather, we will be applying this concept in an important branch of mathematics called as calculus. So it is very, very, very important. Not only calculus. So if you see the name of the next chapter also, right? What is the name of the next chapter? Can you check your textbook and tell me?
Complex numbers and quadratic.
That is fourth chapter. You call it as trigonometric functions. You don't call it as trigonometry. Last year you would have learned it as trigonometry, right? So you learned it as sine theta, cos theta, tan theta. Here we'll not see them as sine theta. We'll see them as sine x. So for sine x, we will define the domain and range. For cos x, we will define the domain and range, which you have not seen before. So for you to understand those basics and for you to have that chapter easy, you need to understand functions. Okay, so concentrate. Any doubt you have, get it clarified, right? So having said this, let's proceed. So the next topic we are going to see is functions, right? So in this section, we will study about a special type of relation. Understand this, that function is obtained as a subset of relation. Okay. So we are going to study about the special type of relation called as function, right? And as I told you, it is one of the most important concepts of mathematics, right? So we can visualize a function as a rule which produces new elements out of some given elements, right? So for which we will be seeing certain terms called as mapping, right? These are the words that we are going to see. Okay, this is a grammar that we are going to use for functions. Shall I proceed? Listen to this. So the definition related to a function is something like this. As we know that function is a special type of relation. The definition of function itself starts with the word relation. So if you define a relation F, so generally relations are represented with the symbol capital R. Here what we are doing is the special type of relations which act as a function is given a name F. So relation F from where? From a set A to another set B is said to be a function, right? That relation can be called as a function provided every element of set A has one and only one image in set B. This is the crucial part on which we need to concentrate. Observe. So what I'm trying to say is, if I have a set A here and if I have a set B here, right? Let's say I have the elements 1, 2, 3. And if I'm defining a relation, y is equal to 2x, for instance. Okay, there is a relation as of now, where I took the set A to be the first 3 natural numbers. Set B is, let's say, first 5 natural numbers. No? 1 is related to 2. Am I right? How did I know that? Because if I substitute 1 here, I'll get the y value as 2. If I substitute 2 here, I'll get this as 4. Am I clear till this point? An important question to be asked is this a relation? In the sense, if I write this as a relation R, I can write this as 1, 2 and 2, 4. Is this a relation? Yes, it is a relation. But is this relation, right? Can I call this kind of a relation as a function? Now I'm going to check the definition. So what are they saying is this relation can be called as a function if this word is important. Every element of set A has one and only one image associated with the element in set B. So what is important for me to be called this as a function? I need to ensure that 3 is also mapped to some number. But in this case, it is not mapped. So this relation cannot be called as a function. Are you able to understand? Second, so we saw a problem, right? We saw an example problem where we had 9, 4, 25. You had 3 minus 3, 2 minus 2, 5 minus 5. So 9 was related to 3, 9 was related to minus 3. 4 to 2, 4 to minus 2, this to this, and this to this. Right? So every element of set A is associated with B. Can I call this relation as a function?
No, because
I
it
can
has
still
2
not call it
elements.
as a function because it should
Two
be
elements.
associated only to one element. So this is also not a function. So now you got a perspective of what is a function. So when can the relation be called as a function? So two things are to be satisfied. What is it? Every element in set A should be mapped to some element. And it should be only one element. So having said that, I will take another example like this. So if I take this as A and B, if I take this to be 1, 2, 3, let's say I take this also as 1, 2, 3. This 1 is mapped to 1, 2 is mapped to 1, and 3 is mapped to 2. Is this a relation? Is this a relation? It is a relation. It is a relation. I can write this as 1, 1, 2, 1, and 3, 2. So relation doesn't impose any condition on how many elements from set A should be mapped to set B. Here, fortunately, everything is mapped okay. But can this relation be called as a function? 3 is? See, this is where we make mistake. Read the definition carefully. Every element from set A should be associated with a unique element in set B. They didn't say that element should not get repeated. So 1 is mapped to 1, 2 is also mapped to 1. But 2 is mapped only to one number. It is still a function. I never imposed a condition saying that the codomain should be exhausted. We never spoke about codomain. We spoke only about the input set. So every element from the input set should be associated with at least one element. So not at least, with only one element of set B. Am I clear with this? So this is also a function only. Okay, so this is a function. Yes. Am I clear? Those who are online, am I clear with this?
Yes, sir.
Yes. So make a note of this. Switching of the fan for 2 minutes. நீங்க அந்த fan off பண்ணிக்கலாம். Clear with this? Right. So codomain does not codomain is not important at all. Based on how the codomain is participating, there is one of the types of functions defined, which we'll see next year. Okay. So what is the other way? What is the other simpler way of understanding what a function is? Right. So in other words, a function with the name f is said to be a relation from a non-empty set A to a non-empty set B such that the domain of this function should be the set A. Means every element should participate in the relation. So the domain of f should be set A and no two distinct ordered pairs. If I look at these two, right, these two are said to be two distinct ordered pairs. No two distinct ordered pairs should have the first element to be the same. The first element should not be the same. For example, if I take this example, right, if I take this, if I write this as a relation, then what am I going to get? R will be equal to, I'll have 9, 3, 9, minus 3. If I look at this, these two are two distinct ordered pairs. The first two elements are same. This is where it failed. It is a relation, but not a function. So this is one point to be strongly registered in your mind. Am I clear with this? Those who are online, am I clear with this?
Yes, sir.
Yeah.
Yes, sir.
Yes. Just give me a minute. Move your left. So we have understood the major part of it. Right now, we need to see some technical definitions associated. Let's see what they are. A minute. The camera switch off. So listen. So if f is a function that is defined from set A to set B, and so obviously what will be the element present in the function? They'll be ordered pairs. So if suppose A comma B is an ordered pair that belongs to the function f, then what we generally say is the function of A is returned to be B. So generally the elements that come, so where A comes from which set? A belongs to the set A and B belongs to set B. If I define that to occur from set A to set B. Am I clear? So how do you read this? You read this as function of A is equal to B. So where this A is called as the independent element, I'm see this is the name something that I gave for us to have a discussion. This is an independent element and this is going to be the dependent element. So why I say this as independent and dependent is because the ultimate aim of view learning functions is to plot something on a graph sheet. You're able to understand. So what you will do is going forward, we'll see how to plot a given function on a graph sheet. So if I have to understand that, then I need to know these terms of independent and dependent elements, right? So am I clear till this point? So this is something I gave, but yeah, let's see what is the technical name given to it. Then f of A is equal to B, where B is called as the image of the element A under the function f. And A is said to be obviously one side is image means the other side will be pre-image, right? It's called as the pre-image of B under the operation f. So going forward, if I use the word image or pre-image, you should not get confused. So we are just trying to build a language for functions to understand, to be on the common page. Okay. This is one thing. I hope I'm clear with this. So this is one thing. Next is, how do I mathematically represent a function? See, the function f from A to B is denoted as f is mapped, those two dots, f is mapped from A to B. So this is how you mathematically represent it, where the set A by default should be called as the, what set is it? So the element is independent. It's not independent set. It is the domain set, because what did the definition tell us? The set A by default should be the domain, but B is not. So what is the opposite of domain? Like we generally think of range, because it's participating, but B is not range. B is codomain. Because for a function to be defined, we never impose the condition on codomain. But what is the important condition imposed on domain? A should be the domain. If it is not, it's gone. It's not a function, it's only a relation. Even if one element does not participate in the relation, it's not a function at all. So that is why by default A should be the domain and B is called as the codomain. There might be possibilities where the codomain is equal to range. That depends only for specific functions. Not every function follows it, but every function follows this one, right? So these two are important points. Please make a note of it. Can I proceed? Yes. So here they have spoken about examples, but those examples are not there here. Okay. We'll directly go to the problems. So let's look at this example number 10. So let n be the set of natural numbers and the relation R defined on n. So what do you mean by relation R is defined on n? Meaning set A is n, set B is also n. That is the meaning of that statement. Okay. A relation R is defined on n such that the relation follows a specific condition. What is it? Y should be equal to 2x, where the elements participating are x, y. So if I take the elements to be 1, 2, 3, 4, so on. So here what will I have? 1, 2, 3, 4, 5, 6, so on, right? 1 is mapped to 2, 2 is mapped to 4, 3 is mapped to 6. Like this, it keeps on going, right? So first question to be answered, is this function, sorry, is this relation a function? Yes, it is a function. Because for every natural number n that you're going to introduce, for every natural number n that you're going to introduce, you will have an image 2n associated with it. So every element, every unique element is having only one image associated. Hence, this is a function. So that's what they have asked here. Is this relation a function? Yes, it is a function. Okay. Second, what is the domain, codomain, and range of this R? So what is the domain of this?
N.
So domain is natural number set. Because how is this relation defined as? F is a function map from natural number set to natural number set, where this natural number set is the domain set, this natural number set is codomain set. Right? So obviously domain is going to be natural number. What is the codomain? What is the range? Basically, they are even natural numbers. Right? They are going to be, if you have to write it in this format, it is going to be 2, 4, 6, 8. It keeps on going. Clear with this? 2n, where n belongs to natural numbers. Are you able to understand? These are all the different ways in which you can write it. Okay, please make a note of this.
So in this case, codomain and range both are the same, right?
No. In codomain, 1, 3, 5, they are not participating. No.
Oh.
You're able to understand?
Yeah, sir.
Yes.
Sir, so domain and codomain are same.
Domain and codomain, how will they be same? Domain is 1, 2. So you will never have a comparison of what is. Oh, sorry. You're right. In this case, yes, domain and codomain are same, because this you can say from here itself. Defined on n itself will tell you that domain and codomain are same.
So since there's one set, so it will be the same.
Yes.
So
Okay.
one note, sir. But domain starts from 1, sir. But whereas in codomain it starts from 2, right?
Codomain is also starting from 1 only.
Oh.
Codomain is a complete set.
Okay.
Range is a set of elements which are participating in the relation.
Yes. Okay. In that case.
So to put it simple, no, to make you understand, this arrow mark is coming and falling at one point. No. So this is the number. This 2 is the number with which it starts. So from codomain set, only those elements which are 2, 4, 6, 8 are a part of the relation. Sorry, part of the function. 1, 3, do they have any pre-images?
No.
So that is why they both are not same. Okay. So this is how the answer is given. The domain of R is a set of natural number. The codomain is also natural number. Right. So the range is set of even natural numbers. So they have given it theoretically, but we wrote it mathematically, right? Since every natural number n has one and only one image, this relation is said to be a function. So this is how you report the answer in your exam. Next. So example 11. Examine each of the following relations given below and state in each case giving reasons whether it is a function or not. So when they give something in the roster form, the only thing that you need to do is take two distinct ordered pairs, look at the first element. If the first elements are same, not a function. They are not same, it's a function. So observe this. So observe this. 2 1 3 1 4 2. 2 2 2 4.
Not a function.
1 2 2 3 3 4. Oh, sorry. Somewhere 1 2 2 3 3 4 4 5 5 6 6 7. Yes, it's a function. It's a function. Right. See, all these things that I'm writing, if you have textbook, you can just make a note there itself. Have a pencil, just make a note of that. So what were they? First one is function, no? Second, not a function. Third is a function. So the next definition that we are going to see is, right? A function which has either R. Here R does not stand for relation. R is the real number set. Real number set. So a function which has either R or one of its subsets. So one of its subsets means what are the subsets of real number? Natural number, rational number, irrational number, whole number, integer. It can be anything. I give it. அங்க அந்த இங்க் மட்டும் போய் எடுத்துருங்க போதும். Okay. So a function which has either R real number set or one of its subsets as its range, then those type of functions are called as real valued function. Further, if its domain is also either or subset of R, it is called as a real function. Understand the difference. So when I say real valued function, the output is coming as a real number. When I call it as a real function, the input is also a real number or subset of real. That's it. So by now you would have understood what I mean by input and output. Anything that is a part of the first set is input or output. Obviously input. So this is the input set and this is the output. So please make a note of this. So going forward, we are going to discuss only real functions and real valued functions. Shall I proceed?
Yes, sir.
Yes, sir.
So with this, the theory part is over. Now we'll concentrate on problems. So example 12. Let n be the set of natural numbers. Okay. Define a real valued function f map from n to n such that f of x is given as 2x plus 1. Using this definition, complete the table that is given below. It's very simple. Like in your 9th grade, if they give you a polynomial and ask you to substitute the values inside, what will you do? You'll just keep plugging in the values, right? Same thing. So there, whatever you have learned, no, that is also called as a function. It's called as a polynomial function. Okay. So here x is equal to 1. I put x is equal to 1 here. What will I get? 2. So basically, it forms an arithmetic progression. Right? So define a real valued function if mapped from n to n is given by f of x is equal to x plus 1. Using the definition, complete the table. It's simple. So this is all you need to do. You need to just complete the table by plugging in the value. Right? So they have already defined. Yes, they have given the function. Yes, 2x plus 1 is the real value. Okay. Now what we'll see is, we'll see some important functions and their graphs. So the first type of function that we are going to see is an identity function. Name itself is suggesting identity means whatever input you get the same output. If you give 1 as the input, you will get 1 as the output. You give 2 as the input, 2 as the output. So if that is the case, how should the function look like? So basically, it should look like the format y is equal to x. Right? So let R be the set of real numbers. Define the real valued functions f map from R to R given by, you write the function like this. You write y is equal to f of x or simply f of x or sometimes simply y. So you write it as y is equal to f of x is equal to, this is where the function will get defined. Here the simplest form is the function is x only. So f of x is equal to x for each x that belongs to the real number. Meaning you take any real number, you plug in a real number here, you will get a real number out. Okay. So if you are able to define such a function, this is called as the identity function. I told you the reason why. Because the input and the output are same. So that's why it's identity. So here the domain and range of the function are going to be Rx. Means if you give a real number input, you will get exactly the same real number as the output. Right? So how is the graph going to look like? Obviously, the graph is going to be a straight line. We know that the linear equation in two variables is a straight line. So y is equal to x is going to be a graph that is passing through the origin. So it's given here. See, this is going to be the graph that will pass through the origin, and it will be symmetric with respect to the first and the third quadrant. So it will not have any participation in the second and the fourth quadrant. It will have participation only in the first and the obvious reasons. Because in the first quadrant, both are positive. Second quadrant, both are negative. Okay. So this angle is going to be 45 degrees. It exactly be an angular bisector of the quadrants. So there are multiple ways of perceiving this. So this is what is called as y is equal to x in terms of definition, mathematical definition. But what is the name given to this kind of a function? We call it as identity function. Am I clear with this? So I just want to stress on one point. Listen to this. You are writing y is equal to x, no? So if suppose the question was y is equal to x plus 1, do you think this graph would have passed through origin? So for that matter, you take any expression in this world, any mathematical expression that does not have a constant added or subtracted to it. I'm not talking about multiplied. If you don't have any constant added or subtracted to it, here if you observe y is equal to x, are you able to see any constant? X is a variable, y is also a variable, right? So there is no constant added to it, it will always pass through the origin. This is applicable for any graph, any mathematical equation. Any mathematical equation that does not have a constant added or subtracted will always pass through the origin. Shall I proceed?
Yes, sir.
Listen. The second type of function that we are going to see is constant function. See, all these while we would have discussed it as a constant. Right? For example, 2 is a number which is a constant, 3 is a constant, 4 is a constant. But can I define that constant number as a function? Yes, I can do that. How am I supposed to do that? If you are able to define a real valued function f mapped from R to R such that y is equal to f of x is equal to some number c, is equal to some number c, and where x belongs to R, then so where c is a constant, and for each x that belongs to R, this can be called as a constant function. So here, what is going to be the domain? The domain set is going to be real numbers, right? What is going to be the range? The range will not be the real number. It will only be one number c. Because if I define y is equal to f of x is equal to, for example, 3. What is the meaning of it? Whatever is the value of real number, I am going to substitute here. F of 1, what am I going to get? F of 2, what am I going to get? 1.5. So if I substitute any real number from the domain set, the output is always going to be 3. Hence, the range for this kind of a function is a constant itself. So the range of this function is just the element c. That's it. Am I clear with that? Right? So when you plot the graph for this, right, when something like this y is equal to constant is appearing, the graph will be parallel to the x-axis. It can either be above the x-axis or below the x-axis. If the value of constant is positive, it is above the x-axis. For example, if I look at this, I don't know what this number is. I'm assuming it to be 3. It is given as y is equal. Okay, the function is given. F of x is equal to 3. Y is equal to 3 is a graph which is parallel to x-axis above it. Suppose I give you a function f of x is equal to -3. There will be a graph below x-axis exactly parallel to it. Are you able to understand? So this is how constant functions work. So graph is a line parallel to x-axis. For example, f of x is equal to 3 for each x that belongs to R, then its graph will be a line which is shown like this. Okay, so you can make a note of this.
So it's
Am I
called
clear,
a
guys?
constant function because the range remains remains constant every time.
Because right side f of x is equal to 3. See, for example, if the question had been f of x is equal to 3x, this is not a constant function. Because you substitute different values of x here, you get different values of y. Whereas in this question, what is there? F of x is equal to 3 is there.
Yeah.
So whatever is the value of x that you're going to substitute, the output is not affected at all. It's a constant.
Yes, understood.
Yes. So the third type of function that we are going to see is a polynomial function. This is something you have learned in your lower grades. You have learned in the name of polynomial, you're just adding a tag to it called as a function. So polynomial function. If we are able to define a function f which is mapped from real numbers to real number, you can call it as a polynomial function if for every x that you substitute from the domain, you take a value from the domain and you define the function y is equal to f of x such that f of x is a0 plus a1x plus a2x square plus so on till an x power n. Right? Where n is what? N is a non-negative integer, and at the same time, the constants which are the coefficients a0, a1, a2, so on till an can be any real number. They can be fractions, but the power of n, the power n should not be a fraction. Okay. So for example, if I look at them, f of x is equal to x cube minus x square plus 2. Is this a polynomial function? So is it satisfying both? Look at the powers. It's a non-negative number, and look at the coefficients. They are real numbers. So when I say real numbers, they can be positive or negative. If I define another function g of x, which is equal to x power 4 plus root 2x, it is a polynomial function because the powers are non-negative. See, they should be non-negative at the same time. They should not be a fraction. They should be a whole number. Okay. Are some examples of polynomial function. Whereas if I define a function h of x is equal to x power 2 by 3 plus 2 power 2x, is this a polynomial function? It's not a polynomial because the power of x is fraction. It's not a whole number. Hence, this is not a polynomial function. So 2 points are to be added where n is non-negative integer. They told integer. Sorry. Non-negative integer is basically a whole number also. So when I say non-negative integer, here you can take 0 also. Okay. So please make a note of this. Done?
Yes, sir.
Yes.
So example 13, define the function f map from R to R, right? Given by y is equal to f of x is equal to x square. So when they say define the function, no, if they're not asking you to define, they have defined a function. Okay, where the input values that you give comes from the set R obviously. Complete the table given below by using the definition. What are the domain and range of this function? Draw the graph of it. So I have x is equal to minus 4. If I substitute it here, what will I get? So you're going to get the values like this. It's not identity. It's identity, this and this should be the same. It's not an identity function. It's a polynomial function, x square. Right. So if I have to plot the graph for this, then how does it look like? So when x is equal to 0, I'm getting a 0. When x is equal to 1, I'm getting 1. When x is equal to 2, I'm getting a 4. When x is equal to 3, I'm getting a 9. So the graph keeps going like this. And on the other side, it will be symmetrical. So basically, it looks like a U-shaped graph. This is what you would have learned in your lower grades, right? So whenever you have a quadratic equation, ax square plus bx plus c, if a is greater than 0, if a is greater than 0, then what does it represent? It represents an upward parabola. If you observe in this case, here it is y is equal to x square. There is no constant added or subtracted to it. So obviously this should pass through the origin. That's why it passed through the origin. At the same time, it is an upward parabola. So this is an upward parabola. Am I clear with this? Yes, make a note of this. So this is how the graph will look like. So this is the solution actually. Right. Now, the next example is draw the graph of the function f which is mapped from R to R defined by f of x is equal to x cube. So whenever you're asked to draw the graph, right? Observe here f of x is equal to x cube. This is something you would have done in your lower grades. When you put x is equal to 0, y is 0. So remember, this is y also. When you put x is equal to 1, you get y is equal to 1. When you put x is equal to, you get y is equal to 8. X is equal to 3, you get y is equal to 27. Suppose if I put x is equal to -1, I get y is equal to -1. If I put x is equal to -2, I get y is equal to -8. If I put x is equal to -3, I get y is equal to -.
So
So the meaning of this is when x is equal to 0, you get a 0. When x is equal to 1, you get a 1. When x is equal to, you get 8, 27. The graph keeps going like this. Okay. The graph keeps going like this. And the same thing happens on the other side as well. Okay, it keeps going like this. So this is the graph for y is equal to x cube. So by now you would have understood how to draw the graph also. Just need to take the values, plug in, find out the y values, plot it. This is just a cubic polynomial. That's just x cube. That's this graph. Okay. So to be more specific, the graph will look something like this. See, that's what they did. No, just substitute the values and then see. It looks something like this. So the next type of function that we need to see is a rational function. So you know what is a rational number? So rational number is basically of the form p by q, where q is not equal to 0. At the same time, p and q are integers. They're integers, right? But when it comes to rational functions, right, the only difference is this p by q is converted to p of x divided by q of x, where q of x is not equal to 0. And an important point to be noted here is p of x and q of x are polynomial functions. So if you are able to define the ratio of two polynomial functions such that the denominator polynomial function is not equal to 0, then you call that kind of a function as a rational function. Okay. Clear with this? Okay, listen. So look at an example 15. Define the real valued function f map from r minus 0 to r. Why they write it as r minus 0 to r is observed. It is defined as f of x is equal to 1 by x. If you look at this ratio, right, numerator is a constant, denominator is a function. But constant, remember, it can also be called as a constant polynomial. Similarly, the denominator is also a polynomial. So the function which is defined as the ratio of a polynomial to another polynomial will be a rational function. This is an example of rational function. But for a rational function, what is the important point to be kept in your mind? The denominator should not be equal to 0. Meaning, what value can I substitute in the place of x which can make this function a 0? So which can make this function undefined? So I cannot substitute. I can substitute any number in the place of x in the denominator except 0. That is why they wrote it as r minus 0. So you can substitute any real number except 0. But what will be the output? You substitute any real number except 0, the output will definitely be some real number. That is why the domain is like that, the codomain is like that. Yes. So that is the meaning. So how you should perceive this is, see, for example, I give you real number minus 1, 2. What is the meaning of this? I can substitute any real number except the numbers 1 and 2. That is the meaning. Right? If they are limited numbers, you write it like this. If they are infinite set, you write it in the general form. Okay. How to write in the general form, I'll explain you. You will learn that how to write in the general form in the next chapter. That I'll tell you. Okay. So we need to complete the table given below using this definition. So what is the domain and range of this function? So what is the domain of this function? They have already given. Domain is r minus 0. What is the range of this function? So here are we getting r? Yes. You will get r, but is there a possibility for you to get a 0? You can get any real number. Let's check that. So when I put y is equal to 1 by x, answer is minus 1 by 2. Here it is minus 2 by 3, minus 1, minus 2, 4, 2, 1, 1 by 1.5. It's 2 by 3. This 1.5 is substituted in the denominator. So this is half. Okay. So if you look at the graph of this kind of a function, right, it will be something like this. So this graph has a name called as a rectangular hyperbola. You will not learn it in your CBSE, but you can know the name of it. In physics also you'll apply it. When you learn in thermodynamics, right, we'll be learning some graphs. There you will see these kind of graphs. This is called as rectangular hyperbola. Not every rational function, only for 1 by x you will. This graph is obtained only for 1 by x. You can take anything, 2 by x, 3 by x also. Yes, numerator can be anything, any constant. See, if it is a positive constant, you will get a graph like this. If it is a negative constant, you will get the graph confined to second and fourth quadrant. See, graph will change like that. Okay. So one thing I asked you, you look at this graph, right? So one thing we need to say is codomain is real number, but the range is any real number except 0, because you can never obtain 0. In 1 by x, if I have to get a 0, then x should be infinity, I need to substitute a very, very, very big number. So if I substitute x is equal to infinity, then 1 by x will give me a 0. So domain is all real numbers except 0, and its range is also all real numbers except 0. Okay. So then you have three other types of functions. One is called as modulus, signum, and you have something called as greatest bit. Then we have the algebra of real numbers. Sorry, algebra of functions. Okay. So this part I will discuss it in the next class. If time permits, right, I'll record and send it to you. If I have time, I'll record these three functions and send it to you. I'll define the algebra part also, so that by the next week, before you come, you can go through the concepts. I'll solve problems in class. Okay. I hope it is clear till this point, no? So these exercise problems, the simple ones, you can try it out. You need not wait for me. These are all very simple. This part alone, I'll teach you how to find the domain and range and all. If at all they give you this kind of function, right? I'll teach you. So this one you can do it. This you can do. You can do. That's a very simple thing. Actually speaking, this chapter is over, but I have to teach you those three types of functions. Okay. Other means it is simple only. But I want to focus on one more thing, which is not a part of your CBSE syllabus. They would have not gone in depth of how to find domain and range for all functions. That practice alone I'll give you. Because I want you to solve any kind of a problem. It's not about CBSE. You know. Suddenly you want to write competitive exam, at that time you should not stop. Okay. Am I clear till this point? So you can revise and practice the problems. The remaining things I'll see it in the next class. Okay. Those are online. You can leave.
Thank you, sir.
Thank you, sir.